Hello guys, now we are talking about single cycle data path. It's a fundamental concept in computer architecture that shows how a processor executes each instruction in exactly one clock cycle. Let's break it down clearly and explain. First, what is single cycle data path? A CPU data journey, how every instruction travels from fetch to write back in a single clock cycle. The core components, the CPU toolkit. Program counter. Program counter holds address of next instruction. Update after each instruction. Instruction memory. Stores instruction. PC is used to fetch instruction. Register file. Containing register. How active data with fast read and write ports. It supports read and write. ALU. Perform operations like addition, subtraction and or. Data memory. Used in load and store instruction. Read or write data. There are five stages of a single cycle. Fetch, instruction decode, execute, memory access and write back. All the steps are executed in a single clock cycle. Working of a single cycle data path. Step 1. Instruction fetch. Program counter retrieves the next instruction from instruction memory. Instruction is fetched now. The next step is instruction decode. Instruction is split into opcode and operand. Control unit generates a control signals here. Third step, execute. ALU perform operations. Example, add, addition for add, comparison for branch equal. Next step is memory access. If we need a load, read from memory, store, write to memory. Write back. The operation result is written back into the appropriate register in the register file. Instruction fetch. It is the starting point of every instruction. PC sends the address, fetch the instruction and the program counter is increased by 4. Every instruction begins its journey here. R-type instruction. The calculation view. Example, add, sub and or. There are 4 steps. Fetch the instruction, read source register, ALU execute, write back. Here there is no memory access. In R-type instruction we do not use any memory. Fetch instruction. Read the instruction from memory using the program counter. Read source registers. There are 2 source registers in R-type instruction or read from the register file. Executes. The ALU operations are performed here. Example, add, sub and or. There is no use of memory access here. Write back. The results are written in destination register. For load and store operation, for load and store instruction, data moves from fetch the instruction from memory, read base register and exact offset, ALU calculates the memory address. And if it is load, read data from data memory, write to register. If it is store, write data from register to data memory. Here in the ALU operation, the calculation is base plus offset. It is a effective address calculating. The ALU computes the target memory address by adding a base register value to an immediate offset. For load operation, data flows from memory to a register. For store operation, data flows from a register to memory. Both complete in one clock cycle. This is the slowest path and the determinant of overall cycle instruction. In load, the final result are stored in register, but in store, the final result are written in memory, not register. Branch instruction. Example, branch B, branch equal. If it is equal, jumps to the next line. If it is not equal, moves to the next line. Here there is fetch instruction, read ALU operation, update the PC. There is no write back and memory access here. Compared to register, if equal, program counter jumps. Control signals. The control unit acts as the CPU controller, generates the visual signals that direct the flow of data on the operation within the data path, ensuring each instruction is executed precisely. Signals and its function. Register destination determines which register receives the write back result. ALU source. Select the second operand of the ALU operation, register or immediate value. Mem-read enables reading data from data memory. Mem-write enables writing data to data memory. Mem-to register. Mem-to-reg chooses between ALU result or memory data for register write back. Register write activates the write operation to the register file. Branch indicates whether a conditional branch should be taken. ALU op specify the operation the ALU should perform. Important concept. Clock cycle is determined by the time taken by the slowest instruction. Example, in load instruction takes the longest time, so it determines the clock time. A single cycle trade-off, simplicity versus speed. In single cycle data path, every instruction completes in exactly one cycle. Simple and predictable, easy to understand. The disadvantage is clock cycle must be long enough for the slowest instruction. Typically load and store, it takes more time. Faster instruction like OR type and branch decision, it takes little time and it sits idle, wasting potential performance. The future pipeline. A single cycle data is the foundation of CPU design, but real-world processors go further. If fetch instruction happen for one instruction, the next step is decode. Instruction 1 decode it, instruction 2 fetch the operation. So simultaneously the process are done. Pipelining allows multiple instructions to occupy different stages simultaneously, dramatically improving throughput without increasing clock speed. Simple diagram explanation. Program counter, instruction memory, register file, ALU, data memory and register file. This is the step 2 single cycle data path. Control unit controls the entire flow. Summary. One instruction per cycle. All operations happen simultaneously. Simple but inefficient. Basics for understanding advanced designs. Thank you.